Hello everyone, today we're going to talk about section 11.5, which is on more three-dimensional figures and specifically calculating the volume of prisms and cylinders. So we had also talked earlier about pyramids and cones. We're going to save those for a little bit later and just focus on the volume of the prisms and cylinders. So let's discuss volume. Volume, we had originally talked about how it was the amount of space that something takes up. Another kind of definition is the number of cubic units that are contained in the interior of a solid. So once again, we had talked about maybe filling something up with water. So right here, the amount of water used to fill a brand new cup. That would be your volume right there. Here's your general formula for volume, and this is going to be true all the time. So I think that this is a really great one to start with, because if you can only remember one formula from today, it should be this one. If you want to find the volume of a three-dimensional figure, you need to figure out what the area of the base is and then multiply that by the height. It's very simple and straightforward, and so that works out great. And it really doesn't matter what the base looks like. You're going to find the area of it, and then you're going to multiply it by the height, and you'll be good to go. Just a quick note about height. Remember that the height always needs to be perpendicular to the base. That's really key. So if it's not perpendicular, you're going to need to find the height that is. And so that might take a little extra work. Let's break this general formula down a little bit. So now I'm going to show you some specific formulas for some of these guys right here. Some of them will be more specific than others. And if you try to memorize them all, that's not going to work out very well. But luckily, you have a lot of previous knowledge and you have this great general formula, so you should be able to cover your bases pretty easily. Okay, cubes. So cubes are really great because all the side lengths on a cube are going to be the exact same, which means that when you calculate the volume of the cube, it's going to work out great. The base of this cube is going to be a width of S and a depth of S. So to calculate that area right there, it would be S times S. And then what you would want to do is you would then want to multiply that by the actual height of the cube itself. So the distance between the base at the bottom and the base at the top, that is also going to be S. And so that means you're going to do S times another S. That's a lot of S's and they're all the same. And so what mathematicians have done is simplify that a little bit. That is the same as S cubed. So there's your volume formula for a cube. It's very unique. It works out really great because it's so simple. Okay, so now prisms. This one is going to be the least satisfying answer that I have for you. So here's the deal for prisms. Once again, you need to know what the volume of the area of the base is, and then you need to multiply it by the height. And that is about as specific as I'd like to get. Because for a prism, the base can look a lot of different ways. And so when you calculate the area of that base, no matter whatever technique you use, then you can multiply by your height and you're good to go. Notice that I'm using a big B for base because I want you to understand that is the area. That's a calculation that needs to be performed there. It's not just simply a number that you can read off. So if you take a look at what I have right here, this base right here is a triangle. So if I wanted the area of that, I would have to do 1/2 base times height. Now that's a little b right there. That's for the base of this triangle. So that would be like this distance right here. And then the height I would be talking about would be the distance from that base up here to that vertex up there at the top. Then after that, what I would then do is I would need to take that base area and multiply it by the actual height of the actual prism. And so that would get multiplied by a separate h. But a triangle is not the only base you could have. What if your base was a rectangle? Then that rectangle would have an area formula that would be different. It would be base times height. And then you would multiply that by the height of the actual prism. What if it was a pentagon or an octagon or a nonagon? Then you would have to use the theorem 1/2 the apothem times the side length times the number of sides, and then you would multiply that by the height. If it was a rhombus or a kite, you would need to use the diagonals to find the area of the base and then multiply that by the height. If it was a trapezoid, you would have to average the two bases of the trapezoid, multiply that by the height, and then multiply it by the height of the prism. So there's actually a ton of different kinds of versions of this, and it just depends on what your base looks like. And there's too many to list right here, so I think that the general version is going to be your best bet. Lastly, cylinder. So now a cylinder is the round shape. And this is not a polyhedron, but it is certainly a three-dimensional shape, and you can definitely find the volume of this guy. For this one, you want to still find out what the area of the base is and then multiply by the height, but the area formula for the base is pretty specific. For all cylinders, your area for your base is pi r squared, which is going to only rely on knowing the radius. Then once you have that area of that base, you can multiply it by the height and you're good to go. Typically, this guy should really kind of be clustered in with these ones over here, but we're going to give it its own kind of special version so you can kind of see your whole list. If I was going to only memorize one thing on this page, it'd be this. And then hopefully your prior knowledge can help you fill in some of these gaps like we have here and everything that we have over here. It's just too much to try to memorize all at the same time. So just try to focus on this and then use your problem solving to handle this big B right here. Okay, so let's take a look at a couple of example problems. So our first set, what we have right here is I want you to name it first just to practice that skill and then find the volume after that. So this guy right here is going to be a triangular. It's definitely got triangles on it. And then the big question becomes, is it a pyramid or is it a prism? And these bases that we have, these triangular bases, are at the very front and at the back. They're not at the bottom, at the top. So this square or rectangle that you see down here at the bottom, that's not the base. That is not. That's a lateral surface. The bases are going to be the triangles, and they're at the front of the back, not at the bottom or the top. So this is a prism. It has two bases. One's at the front and one's at the back. And we need to find the area of this guy. So to find the area of this, what we want to do is we want to calculate the area of the base first, and then we're going to multiply that by the height. Okay, so our base is a triangle, which means we want to use 1/2 base times height. That's easy to work with. Our base for just our triangle right here is a base of 3, and our height for just our triangle is a height of 1. Okay, so now the height of the actual prism. This second h that we have over here is the height of the actual prism. And for a height of a prism, this is an interesting thing. I want you to know that when we're talking about the height of a prism, that is the distance between your bases. So that doesn't necessarily have to happen vertically like your height on your body, but that is certainly the height of the prism. So in this case, the height of the prism is going to be the distance between this base at the front and this base at the back. So the height is going to run from the front to the back, not from the bottom to the top. So the height that we want is actually 2. Okay, so now if you use these values and you calculate, what you're going to end up with is 3. For units, this is a volume question, so we want to make sure we are going to use our units correctly, and it happens to be feet, and those feet are going to be cubed. Second one. For a second one right here is a little bit more traditional. You can see a base at the bottom and another base at the top. This one's a circular base. You could call it a circular prism, but that doesn't make much sense. It's much better to call this a cone, or sorry, a cylinder. There you go. Okay, so now let's talk about volume formula. So once again, for your volume formula, what you really need is the area of the base, and then you're going to multiply that by the height. Now for the area of the base, it happens to be a very specific formula. It's pi r squared. So we're going to take a pi, we're going to multiply by our radius, which you can see right here is 5, and we're going to square that. After you've got that set up right there, the next piece that you want to do is you want to multiply that by the height. And so our height is going to be the distance between the two bases, and this time it does happen to run vertically, which is great. So we're going to multiply that by 6. When you calculate this value, you're certainly going to get a decimal. Pi always is going to produce a decimal for you. So our volume for this one is going to be 471.24. Our unit that we had for our two measurements was meters. So we want to have meters again, and this time it's going to be meters cubed because it's a volume. All right, second example is going to kind of take this idea and flip it on its head. This is what I sometimes call a Jeopardy question because they kind of give you the answer and they ask for the question part. So if you take a look right here, it says the volume of the right cylinder is 1,253. Now that's actually what we were working so hard to find for the last two problems, was to find the volume, and now all of a sudden they're just handing it out. And what they want to know is they want us to find x. Well, what does x represent? X actually represents the radius of the circle base, or the circular base. And so that's what we're trying to figure out. Okay, so our formula is volume is equal to pi r squared times the height. Let's plug in as many things as we can. Starting with the volume, that's 1,253, and that is going to be our v value. Pi is going to stay pi, so we're going to keep that the same. R squared, that is the distance that we're trying to find. We don't know what r is, so I'm going to replace it with the variable x like they had mentioned here, and I am still going to square it. Height, we do know what the height is. The height is 10. Okay, so I need to get that x variable right there to get my answer. And the way that I'm going to get the x is by removing all of the numbers that are in front of it, behind it, and above it. And I'm going to remove them one at a time. I'm also going to use opposite operations to do this properly. So let's start with the 10. I'm going to take care of the 10 by dividing everything by 10. That is going to give us 125.3. And that's going to be equal to pi times x squared. Okay, next I want to remove the pi. And the way that you're going to remove the pi is, once again, another opposite operation. Pi is being multiplied by x, so the opposite operation would be to divide it. You could do the division of 10 and pi at the same time. It would work out fine. I'm choosing to do it separately because this is our first round, and I wanted to go slow so that you can follow along pretty easily. 125.3 divided by pi is going to give us a big decimal, and that's okay. There's nothing wrong with having decimals in these problems. That is going to give us 39.88. And then our last step right here. Our last step is to get rid of the power of 2. So now this is the trickiest one. This is one where people make mistakes. To get rid of a power of 2, you're not going to divide or multiply by anything. You're going to take a square root. We're also going to take the square root of our new 39. And when we take the square root of that guy, we're going to end up with a very small value, which is going to be 6. Let's talk units. So you can tell right here that the units need to be centimeters. They're not going to be cubed this time because it's not a volume. We already had our cubic centimeters right up here, so we don't need to have cubics on these. It's just going to be centimeters, and you're done. So opposite operations really save the day on this one. You just work your way through the problem after you get it set up, and you're good to go. All right, let's talk about actually calculating some unique ones. So a couple of different things we can do to make these problems more complicated. One thing is we can make it look weird. So if you take a look at what we have right here and right here, you're going to notice that what we have is not just a nice straight up and down prism. What we have is one that is kind of tilted. Now that definitely looks strange, but the great news is that we have a great ancient mathematician right here, Calavari, and Calavari's principle states that it doesn't matter if it's slanted or not. The volumes are going to stay the same. Specifically, it says if two solids have the same height, which these two have, and the same cross-sectional area, so that's those same planes that slice through, then they're going to have the exact same volume. The best way that I know to think about this problem is if you were talking about a stack of quarters. So if you had your quarters stacked up right on top of each other, there would be a particular number of quarters. It would weigh a particular amount of weight, and it would have a particular height, and that would work out great. If you took that same exact stack of quarters, and if you, instead of stacking them directly one on top of the other, if you kind of ever so slightly moved one a little bit to the far right or to the far left, then what you're going to end up doing is kind of having kind of like a leaning Tower of Pisa. And if you stack just carefully, you should be able to get them to stack without breaking. And now they're still the same height, they're still the same weight, they're still the same volume, but they look different. The height is now going to be measured out here off to the side as opposed to right through the middle. But that doesn't change the calculation at all. So if you take a look at this guy right here, this is another prism. This is a pentagonal prism, and it has been, once again, kind of leaned over. It's kind of got a little bit of a slant to it. And so we need to see if we can calculate the volume of this guy right here. So to begin with, our formula that we know is area of the base times the height. So if we can figure out those two things, we're good to go. So I'm going to start off with finding the area of the base. So that means I'm just really looking at the pentagon, and I'm not really focused on the lateral surfaces between the two pentagons. Now, this is a super, super generous pentagon. It's actually really nice. So getting the area should be pretty quick. The area formula that we're going to use is 1/2 the apothem times the side length times the number of sides. And we have all of the information that we need, which is super great. That's very generous. It's because it's a notes problem. I can make the problems a lot harder by taking away some of these facts. So the apothem right here is given to us. It's labeled on the drawing as being 8. The side length is also labeled. It happens to be over here. It's 11.62. That would usually typically something we would find using SOHCAHTOA, but this time it's given to us. And then the number of sides, we already talked about how it's a pentagon. It has 5 sides. All right, so now to calculate the area of this is just a little plug and chug. Type it into your calculator, and you should be able to get yourself a good value to go with this. And it's going to be 232.4. Okay, height. So now height right here would be the height from the first base down here at the bottom to the top. Now the deal here is for your height is that it needs to be perpendicular to the base. And so just like we saw in the Calavari's principle illustration, you can see that that height needs to maybe be outside of the figure, and it needs to have that right angle. And you can see it when I did my quarter stacking, that it is going to have that right angle, and it is going to be kind of outside of the figure. You can find the height that we need for our problem right over here, which is not actually part of the problem itself. We have that right angle right down here, which is great. And they actually even gave us this angle right here, which is going to be 73.74. There is actually one more piece that is given to us, and that's the 25. This side length of 25 is consistent, and it's going to show up here and here. And more importantly, it's also going to show up here. So now, because of the right angle and this collection of information, what you might notice is that you're actually looking at a little right triangle. It has a hypotenuse, which is 25. It has a 90-degree angle. It has a height, which we need to find. And it has an angle measure inside here of 73.74. Okay, great. That right triangle means that we can use our right triangle tools to find the height, and so we should. Our three basic right triangle tools are a squared plus b squared equals c squared. We won't be able to use that. We don't have enough lengths. We also have the 180 trick, or the triangle sum theorem. We don't really need it. I need a height, which is a distance. I don't need an angle measure. And then lastly, our strongest trick is SOHCAHTOA. And that's the one we're going to use right here. It uses angle measures and side lengths to find all kinds of new information, including other side lengths. So let's use it. If I'm using SOHCAHTOA, I'm going to need to identify what kinds of sides I have. 73.74 is the angle I'm going to focus my time and effort on. H is opposite of that 73.74, and 25 is a hypotenuse, which we had already talked about earlier. It is the longest side. So which operation uses opposite and hypotenuse? That's SO, or sine. Sine always gets matched up with your angle, which is 73.74. And then our two side lengths get paired up in a fraction. And you want to make sure you do your opposite first and your hypotenuse last, because that's the way it's spelled out. All right, excellent. Now we can solve. I'm going to create a fraction by writing this over 1 and cross multiply. That's going to give me h is equal to 25 times the sine of 73.74. And this is actually what you're going to type into your calculator. So when you do type it in, you're going to get a height value, and this height value happens to be 24.00, or just 24. So now we know what our height value is going to be. Okay, so now to get the actual area for this prism right over here, our volume formula is, once again, the area of the base times the height. We had to work to collect both of those pieces of information, but now that we have them, we can just plug them in and solve. So our height was area of our base was 232.4. And our height we found to be 24. And when you multiply those two values together, you're going to get your volume. And so our volume this time happens to be pretty large. It's going to be 5,577.6. Now, there aren't a unit on this problem, and sometimes I do that on purpose so that you don't have to worry about it. If you really feel strongly about using units, then you could just use the word units. And if you do that, then you're definitely going to need to make sure that you put a cube on this, because this is a volume. Last one. Last one is what is sometimes referred to as a compound shape. I don't have an area formula for this shape, and I don't have a volume formula for it either. So this is a little bit of a goofy one. In order to deal with this strange shape, your best option is to break it down. So if you take a look right over here, I've kind of redrawn it as two different elements, and you should be able to work with those elements separately, and then you can put them together by adding once you're all done. So let's see if we can work on that. This first element looks like a cylinder. It also looks like a cylinder that's been cut in half. So I'm going to work on cylinders first. So cylinder formula is usually pi times your radius squared, and then you're going to multiply that by your height. I want to use the same formula, but I also want to do something important to it. Since it's half of a cylinder, I want to take the whole formula and multiply it by 1/2. So let's do that. Okay, now let's get some dimensions. So the first thing we need is a radius. Radius would be this dimension right here. Now on the original drawing, it's certainly not labeled for us, but if you're crafty, you can get it. This 4 from down here on the bottom is repeated a second time right over here, which means that the whole distance is 4, but I don't really want that. That's technically the diameter. So I really want the radius, and the radius happens to be half of that, which is going to be 2. So I have it labeled on my drawing, and I'm going to put it into my formula. Now for the height. For a lot of times people, they really want to focus on the height from the bottom to the top. Not a good choice. Once again, your height is your distance between your two bases. So our height is going to be this distance right here. And that distance, once again, is not labeled on the original drawing, but if you're crafty, you can bring the 4 from the bottom up. And so our height is going to be 4 for this guy as well. Okay, now you have everything, and basically you just need to type this into your calculator. I would recommend that you use a 0.5 for the 1/2. That'll make your life a little bit easier. And that's going to give you a value of 25.13. All of these measures were in inches, so this is going to be 25.13 inches cubed. Second one is a cube. It has a width of 4, it has a depth of 4, and it has a height of 4 as well. They're all the same. They're all going to get multiplied by each other, and so the easiest way to calculate this volume right here is to just write it as 4 cubed. Once you've figured out what it's going to look like, you just need to type it into your calculator. That is going to be 4, and then you're going to want to use that special caret button that looks like this. That caret button lets you plug in any power you want. The power that we want is a power of 3. And then once you plugged in your power, then you can hit your enter button and you're good to go. And when you do that, you're going to get 64 inches cubed. Okay, so for our final answer, we want to make sure that we use the volume of that semicircle cylinder and also the volume of the cube itself. So we're going to add both of these pieces together. When you add them up, that's going to give you your final value. So that is 25.13 plus 64, and that addition is going to give you 89.13 inches cubed. Once again, final piece, the one thing that I really think is going to be most beneficial for you to try to memorize is our most general formula, and that is the area of the base times the height. And the other piece that I would really recommend that you memorize is the fact that height is the distance between two bases. It is not the distance from the bottom of a picture to the top of a picture, although sometimes both of those things are the same thing at the same time.